Types of solid wastes: municipal solid waste, industrial wastes, hazardous wastes, biomedical waste, e-waste. Evolution of solid waste management. Solid waste, a consequence of life, waste generation in a technological society. Material flow and waste generation, the development of solid waste management. Integrated solid waste management, planning for integrated waste management, operation of solid waste management system. Unit 2, Municipal solid waste characteristics. Solid waste generation. Composition. Determination of composition. Particle size, heat value, bulk and material density. Types of materials recovered. Mechanical properties. Biodegradability. Unit 3, Collection of solid waste, refuse collection systems. Commercial wastes. Transfer stations. Collection of recyclable materials, litter and street cleanliness, design of collection system. Unit 4, Solid waste processing. Treatment and disposal. Biological process. Composting. Production of biofertilizers and energy. Thermal process. Incineration. Gasification. Wet oxidation. Pyrolysis, palletization and energy production. Waste management through reduce, recycle and reuse. Kitchen waste management, landfills. Classification, types and methods. Design engineering, current issues in solid waste management, public and private ownership and operations, role of the solid waste engineering. 2. Liquid waste management. Unit 1, Introduction, Waste management, an overview, liquid waste management, and municipal, domestic and industrial wastewater, solid wastes, municipal and industrial wastes, environmental engineering and environmental systems. An overview, mass balance approach to problem solving. Unit 2, Wastewater, water resource and its significance. Water, a remarkable substance and impacts surface water, groundwater pollution, water, domestic, black and gray water, industrial and agriculture wastewater. Unit 3, Wastewater treatment flow, sheets, unit operation and unit processes, primary treatment, pre-treatment, screening bar racks, grit removal, communication, flow, equalization, sedimentation, design concepts, secondary treatment, chemical unit process, precipitation, coagulation, disinfection process. Design, biological unit process, nature and kinetic of biological growth, aerobic process. Activated sludge system, trickling filters, UASB oxidation ponds. Process design, advanced techniques, membrane filtration, gas stripping, ion exchange, advanced oxidation process, AOP. Unit 4, Water reuse, water reclamation and reuse, water reclamation technologies, process flow diagrams, public health and environmental issues in water reuse, agriculture and landscape irrigation, groundwater recharge guidelines, risk assessment for water reuse, industrial water reuse, cooling tower makeup water. 3. Hazardous waste management. Unit 1, Introduction, definition and classification of hazardous waste. Need for hazardous waste management, sources of hazardous wastes, effects on community, terminology and classification, storage and collection of hazardous wastes, problems in developing countries. Protection of public health and the environment. Unit 2, Biomedical and chemical wastes. Biomedical wastes, types, management and handling, control of biomedical wastes, chemical waste sources, domestic and industrial, inorganic pollutants. Environmental effects, need for control, treatment and disposal techniques. Physical, chemical and biological processes, health and environmental effects. Unit 3, Physical and chemical treatments. Filtration and separation, chemical precipitation, solidification and stabilization technique, chemical oxidation and reduction. Pervaporation, ozonation, evaporation. Remedial actions, techniques, containment techniques, in situ biotreatment options, site remediation, phytomediation, biofiltration. 4. Waste management rules, regulations and its compliances. 5. Environmental impact assessment and environmental clearances, site authorization and consent to establish and consent to operate from Pollution Control Board of Bihar.